It's my friends again. After a whole 7 minutes of me just watching the first take. I won't be doing multiple takes of this. I already did it before. And what had happened was I didn't record any audio, so I had a 40-minute devlog where nothing was said. And then I realized it made a lot more sense to split these up. And so, here we are, doing single takes of each devlog. Starting devlog 5, I think I'll start to go weekly. And devlog, obviously all 5 of them will be recorded today in probably an hour, tops, maybe 2. But all that aside. Okay, now, I'd finally installed Godot. Whoa! Last devlog, I only had Blender installed, and so I'd only been working with Blender. Now, I'd found out that you can actually install Godot and its launcher on Steam, which is very convenient for me because I hate launching stuff from stuff that isn't Steam. I know it's a little bit silly, but I don't care what you think. Besides, it's a useful tool for telling me how much I've spent on Godot, and at this point in time, I'd spent 15 hours on Godot in one day. That's going to be a pattern you're going to see every day moving forward, is I will spend anywhere between 5 hours and 15 hours consistently. In real life, I'm on day 6 with 60 hours on the clock, but as it stands right now, this is technically day 3 of the devlog. Could have been a few days after day 2. Could have been a week. I'm not entirely sure. But I do remember what I did during this day. So, I'd gone through and I'd set the player up. And how I did that was a number of things. So, first of all, I needed inputs. How do you do inputs? Well, on the top left corner, on the project settings, you're going to have an input map that's available on a window for input settings. And with that, you can program each input to do to label it as a variable, and then you can call that variable later in the script file. That is a lot more fucking ergonomic than Unreal was. Unreal was this huge deal where I had to go in and code in the inputs using the weird visual scripting puzzle piece thing. And then you had to go through and figure out what blah blah blah. It was such a mess, and I tried my best to do it by myself. I could never do it. I always ended up relying on YouTube tutorials, and none of those projects even got this far. So, yippee, I guess. But I'd nailed all the inputs, and once I nailed the inputs, I'd started going back and forth between me and ChatGPT and a specific YouTube tutorial called, I forget what it's called, but I'll put the link in the description. And that had basically given me what I needed in order to get this whole thing to work out. I'm pretty sure the tutorial was specifically about animation trees, but I'm getting a little bit ahead of myself. I'll talk about animation trees shortly. So, last time, I'd completed all the animations. Hooray. All of them are in the animation player, all excited and happy and ready to be used. Great. So, next step, you create an animation tree. Now, this is a very simple animation tree. It's nowhere near done because I don't have all the animations finished yet. Duh. But, as it stands, this is what an animation tree is. You create an individual node for each animation, and the animation tree will create a copy of that node. Then, you'll create separate nodes that blend the two animations together, and if the value is 0, then it stands as 0, and if the value is 1, then it goes into the next blended animation. Now, a funny thing that I discovered or I think the guy discovered, or maybe I found this out, is you can actually go past one and do something like, say, 3. Or, yeah, you can do something like 3. And what that does is it blends too much. It's not supposed to blend this much. It ends up playing the animations together and making them a funny mess. And you can actually go beyond 3. You can make it 10. And just have a full, weird, eldritch abomination of an animation. But we'll go back to 0 for now. 0 is a variable, means that it doesn't blend at all, which means that the very first animation in this long tree, the in, is just the idle. It just plays the idle over and on loop. Very exciting stuff. So, how does this look in script? Well, when scripting it, you'll create an enumerator for each status, and then the status will be this, and then you'll have a variable for how much each is being blended. The variable for idle is automatically null. There isn't a 0 or a 1. It's just the default. So as the variable, or for the cure anim, the animation that's already playing, you put that as idle. And then past that, the variables are all set to 0. And then the enumerator will change how much the blend is for each animation until eventually you have a full set of controls and you have a full animation tree. The controls work separately. That's a series of input maps. So once the inputs are in, you put input, get axis. These tell you where the inputs are, which direction, WASD, etc. And then the move direction is established by the inputs, which, well, it's established technically by the global transformation of your character. But then the move direction plus the apply central force method will cause your character to walk or run in whatever direction you so choose. Yippee! Knowing this, you can create a full basic walk cycle and run by simply adding an if and else statement. That makes your character sort of do a little bit of this, a little bit of that, a little bit of this, just sort of walking around. Okay, so now I have a walk and a run. That was all I really did on day 2, but I'm going to include the rest of the inputs in day 3. I'm going to include the rest of the inputs in also today because it feels a little bit silly to not include them, even though they're all basically the same thing. So today I also programmed the jump, and the jump was done by creating a vector up. The if can jump became a boolean that I went to often. Can jump is decided by a raycast, and a raycast is basically, well, that's not what I wanted. A raycast is a sensor that goes off, and the sensor tells you if A or B is allowed. And the sensor that I have is if can jump and if can't jump. So if can jump, cure anim goes to idle, and then is obviously overturned by the handling animations. If can't jump is falling. So if it can't jump, then it's falling, and then that means that the falling animation plays and all of the fun stuff that's involved with that. Now, I'm not going to sit here and lie to you and say, oh man, I'm a genius. This is my first time coding anything ever, and I managed to brute force my way all the way through. How productive is that? I mean, first of all, it's not an honest reflection of my skill, and second of all, it's leaves an unrealistic goal for you as anybody who might see this and make their own thing. So I'm going to say it as it is. This, specifically the player character as it stands, is a Frankenstein creature of my ideas, a YouTube tutorial on how to make it all work, and ChatGPT's execution. And I'm also not going to say that I just took whatever ChatGPT gave me and I put it back. That's silly, and that doesn't teach me anything. I've actually been trying to go through and understand what each function in variable does and how it effectively works. I've never coded anything before, so this whole thing is very new to me. But as it stands, I think I've been getting a decent grasp so far. I've been sort of experimenting on what works and what doesn't work personally, and I'll send the experiment to ChatGPT, and ChatGPT will tell me why it doesn't work or why it does work. So far, all of them except for 3 have been doesn't work, but I'll get to those 3 a little bit later. So yeah, that's about all I really did for day 3. Day 2 was all about animation. Day 3 was all about getting that animation to actually do something, and that meant setting up the animation tree. That meant setting up the input, the input map, which is so much easier to do than in Unreal. That meant figuring out the raycast. Oh, the twist and pitch pivot. Okay, so technically the camera doesn't automatically work the way that I showed you. I also figured this out during the same day. The way you get the camera to work is you first of all add the camera to the player node, and second of all, you add a twist pivot and a pitch pivot as a sort of arm that you control, similar to how in Unreal you have an arm. Now, I think in Unreal it's actually a lot more ergonomic for the camera, but it's such a non-issue, it's not really that big a deal. The input map for the camera isn't actually a specific button. Actually, it's not a button at all. It's not an input. What it is it tracks the mouse automatically. So immediately, the mouse is in this mode. Wait, where is it? Oh yes. Input event mouse motion. So if you move the mouse, then the mouse goes into mouse captured mode, and then the twist pivot, the twist input, and the pitch input, which are variables that are created by messing around with the twist pivot and pitch pivot. Then it is controlled via your mouse movements, and that's what creates the camera control that allows you to swing around. If you let it just as it is, then what will happen is it'll just go out of control and you'll be able to look through walls and stuff. And so the way you fix that is with the clamp. Pretty simple command. It just tells you, hey, you can't go past this point. Hey, you can't go past this point. Other than that, you're good. And that's about the end of how the clamp works. You don't move the camera. You move the arms with the twist pivot and the pitch pivot, and that's how you get the camera movements. So that's it for day 3. It was animation tree, input mapping, camera controls, and that's it. That's all I did for day 3. The jump I did the next day, but I'll get to that shortly.